Supplemental math videos from Circle Christian School. Degrees, minutes, and seconds. I'm going to start with doing this by calculator way, so that will be for Austin. And for you, Drew, who loves those very strange exact degree measurements of the angles inside the unit circle, this will be for you also. After that, I'm going to attack that little linear and angular speed things. Okay, just a quick little bit on the calculator here, because once you find the right keys, it's not that hard to do this. Most of it is just making sure that number one, that you are in the correct mode, and we'll actually be going back and forth. It depends on what we're dealing with, if we're dealing with the unit circle and radians, or if we're dealing with right triangular trigonometry, which will be a little bit more degree. So if you're not getting the right answer, just realize you probably need to bop back to a different mode here. Default method is radian. The important key for this is going to be your apps key, because up above it is a cool little thing that says angles. Go inside it and you'll see all sorts of wonderful things like the little degree sign and the minute sign. But the more difficult one, especially with the older TI 83s and 84s, is finding the second sign here. And every year I have to go back and kind of remember where it's hiding at. But you'll see it's at the plus sign here, which means you have to use your alpha key to insert it. And then it's just a matter, hey, I want to change to radian. Once you've got all the right little ticky marks up there, all you have to do is hit enter, and it will take it into radian mode. And to go back from radian mode, you're just going to go back into that little angle key. And there's one that has a little arrow to it. I think it's about the, what is it, the fourth one down. And it says, you know, DMS. The little arrow means changing it to degrees, minutes, and seconds. And whoop, there it is. When working with linear and angular measurement, the biggest thing that you have to do is go find arc length. And what we're saying here is, honestly, in our measurements, whether it happens to be centimeter or in the standard inches, we really just want to know, if I took a piece of string, wrapped it around a 240-degree angle here, how far would that be in relationship to the radius? Several different methods here, but personally, I kind of go back to my pizza math here with a circle. Say, for instance, I would like to find the arc length of a circle when our radius equals, let me copy it out of the book here, our radius equals 4. And so to find the length, basically what I need is to find the circumference of the whole circle and then a percent of their circumference. That's pretty much what's happening here. So I just find the regular circumference, so that's circumference pi r, and then you multiply that to the degree over 360, because this part right here is the percent of the pizza that you're speaking about. So, I'm sorry, circumference equals 2 pi r. My bad. Okay, got it in there now. So, I'm just going to start with my 2 and the pi and the 4, and then I'm going to multiply that by our percent, our part of the whole circle, 360 here. For those, we can actually shorten, we can take our 4 here, and we can go into the 36 if you want. Clever little things that happen here. We can do a 3 and a 3 into the 9. This is if you're doing mental math. The rest of you will probably opt for doing a little bit of calculator, but I'm just going to tell you, the more you keep it in a pi form. So let's see, I can take a 3 out of here, an 8 out of here, and so I end up with what, 16. I can, no, that's what it's going to be, 16 pi. And when all said and done, you can just put that into your handy calculator. I would just leave it in the fraction form. Austin will not. He likes the decimal thing. So he'd go 16 divided by the 3. And pi times the pi. And you get 16.76 units. Because I didn't define whether it was inches or otherwise. Now, define linear speed and angular speed. Basically, linear speed is, a revolution here, which happens to be the 2 pi. So I'm really just trying to figure out, if I have a circle here, how it would line out linear speed. How fast is it taking to go 1 revolution? Okay. Let me hit erase so I can get rid of the junk. Well, that's going to use your basic distance equals rate times time. And we have a distance, and what we're looking for is the speed, so we're just taking distance, putting it over time, and that's going to leave us with the r. So arc length, which is going to be that little s there, arc length, I'm not sure why they use s, but they do, over time. So that's pretty much what you've got going on here. That linear speed would be the r, arc length would be the distance, and of course t would be the time. Oops. Now, for angular speed, we're actually talking about what happens, how far a certain angle moves at a certain speed or a certain rate. And this is what we're going to call a central angle. Go back to your geometry. A central angle is an angle off the center. And I'm just going to call it theta because it's going to be variable at any given time. And what we're trying to see is how fast that angle moves around in a complete revolution. Let's investigate a little bit of what happens with linear and angular speeds. We have a circular blade, and of course I had to use a Diablo on a saw that has a diameter of 7.5 inches. Yes, I know this one says that it has 10 inches, but we're going to kind of ignore that because they do make 7.5 inch circular blades too. And it's going to rotate at 2,400 revolutions per minute. Now, if you really want to know who would ever have to know this, in all honesty, my son, who works for Bosch Freud and saw blades and sandpapers, he actually does have to know the revolutions and current equipment and which one works better with their sandpaper. The big thing here is that the Diablo, supposedly because of its carbine tip blade here, it takes the heat. That's the whole really cool thing here, blade thing. But anyway, it takes the heat. That's why it's called Diablo. Just ask any master craftsman. They'll tell you that what they like is anything for or the Diablos. As a matter of fact, when I watch the construction shows, because I like watching the DIY and channels, I always look to see if there's not a red blade rolling around in their little saws. It's kind of neat. So first we're going to find the angular speed of the saw blade per second. So we're going to use our angular speed, the size of the angle, which is basically, in this case, for a revolution, is going to be 2 pi. And we're going to multiply that by the number of revolutions and over 1 minute, but we want to know per second, so we're going to have to do it by seconds. So let's see, we can get rid of the zeros here. We can take the 6 into the 2400, which is going to give us 40 and times the 2. So that's going to give us 80 pi radians for our angular speed. Now, the more difficult one is figuring out the linear speed, that is the speed of the teeth as it cuts through the wood. And so we need to find the arc length over time, which is going to be feet over seconds. Because they want to know that in feet per seconds, but let's remember that what we were here is diameter in inches, so we're going to have to keep in mind that we're going to have to do a conversion here in respects to and the feet. So we know we've got 2400 revolutions. We have our length, which is going to be 1 revolution, or 2 pi, times the radius, so the circumference here. And then we're going to convert it into the seconds. So the first thing we're going to do is take the 2400, 2 pi, 3.25, and we get 1500, trying to remember if it's 1500 or 15,000. Give me a second here. Okay, so it would have been 18,000 pi. And divide that by 12, I get the 1500 pi. And of course, that's going to be over 60 seconds. And so again, we can cross that out. And 150 divided by the 6 is going to give us 25. So it'd be 25 pi feet per second. Okay, now it's your turn to go out, grab some nails, a hammer, learn a little bit about some saw blade stuff. Personally, my favorite saw blade is a jigsaw blade or a bandsaw, and make something pretty for Christmas.